Hello and welcome back to this walking talking mock that I started ages ago and then completely forgot about. It's Further Maths June 2014 and we've actually done quite a bit of it. Okay, right, we're on question 9. Let's get rid of that. Okay. So I hope you all like the new thumbnails that I worked so hard on. They look so professional. Oh, also, I learnt how to edit videos. Yay! So if I do anything stupid in this video, I can just cut it out and you won't even know. So good. But I probably won't bother because you guys know that I make mistakes. Hey, I'm human. Anyway. A to B is parallel to C to D. Is E to F parallel to C to D? You must show your working. Okay. It's told us that these two are parallel. Okay, I'm just gonna, just for the sake of it, I'm gonna work out this angle. Just because I know that I can. It's what you would call supplementary. So let's say DCA is supplementary to BAC. Let's put some arrows on it. Okay. So DCA equals 102. They add up to 180 because they're supplementary. Okay. That's 102. Right. That there is going to be 217. Oh, this is calculated paper, right? Yay, I don't have to add in my head. 360, take away that. Okay, so that's going to be 143. So let me write DCE is 143 because angles around a point add up to 360 degrees. Okay. Now, if these two were parallel, then these two would be supplementary and they would add up to 180. These actually don't add up to 180. They add up to 175. So they're almost parallel. So the fact that they don't add up to 180 proves that they're not parallel. I'm just wondering if there's any other way that you could do it. You could say, how about, forget the 102 and the 143. If I drew that line there, that bit there would have to be 78 because it's alternate to that, because it's parallel. And then if this was parallel, this would be 32 because it's alternate. But 78 add 32 makes 120, doesn't make 115. So that proves that they're not parallel because that can't be 32. Or you could say 115 take away 78 is 37. Yeah, 37. Okay, and 37 should be alternate to 32, but it's not equal, so it's not. So there's a few different ways you can do this. Let me just write down how I was going to do it. Okay, I was going to say DCE plus FEC would equal 180 if EF and CD were parallel, because 143 plus 32 is not equal to 180. So, no. Okay. Number 10. The unit square OABC has these 4 vertices. OABC is mapped onto O, A', B', C' under transformation matrix M. Work out the matrix M. Okay, so this is really easy because to work out the matrix of a transformation, you just need to know where does the point 1, 0 go to, and you write those coordinates here and here, and where does 0, 1 go to, and you write those coordinates there, and that's the whole matrix. So 1, 0 is that, which was A. So where did A get mapped to? A got mapped to over here, which is -1, 0. And then 0, 1 is C, and C got mapped to 0, -1. So that's matrix. And this has a part B to it. It's over here. OABC is mapped to O, A', B', C'. That's seriously how mathematicians pronounce that, in case you're wondering. Or A'. A double dash or A dash dash. Remember double dash? What? Why do they not do that anymore in Mario Kart? I don't know. Actually, I heard they brought it back for the Switch version. Is that true? I don't know. Anyway, this transformation matrix, draw and label. You know, we can do this properly, but you can just kind of tell. Or maybe it's just me. That was -1, 0, 0, -1, and it looked like that. This is the same but with 3, so it's just going to be the same but 3 times bigger. But okay, let's do it slowly and properly. So that first column tells you where 1, 0 goes to. So 1, 0, which is A, goes to -3, 0, which is here. Right, A dash dash. And then that tells you where 0, 1 goes. So 0, -3 goes down there. And then from that you have to work out what is generally happening here. It's been, well, you can think of it as it's been reflected in the, no, you shouldn't think of it like that. Basically, it's been stretched by a negative scale factor. And when you stretch something by a negative scale factor, it flips over as well. So say if you had a triangle here and you enlarge that by a negative scale factor, it would end up like over here and facing the wrong way. That's what negative scale factors do. It does like a swappy thing, swap like that, like a 3D picture. So this has done the same. It's been enlarged by a scale factor of -3. So that will be B dash dash. And you can't, well, you can work out where B goes using the matrix. So if you weren't sure about where B goes, B is the point 1, 1, right? So all you have to do is multiply the matrix by 1, 1, and that will tell you where 1, 1 would end up. So -3 times 1 is -3. 0 times 1 is nothing, so -3. 0 times 1 is 0, -3 times 1 is -3. So Should really have written it that way, but yeah, minus 3 would be the coordinates that it would go to, which is down there. Let's get rid of that. Simplify fully. Okay. Let's KFC this. I can't believe I'm now saying KFC. Like I talk so much about how I hate that, and then I just can't help but say it all the time. Okay, so I've keep, flip, change the sign. That's what C stands for. Change the divide into a times. It's a really rubbish acronym, to be honest. Okay, right. Let's do some cross cancelling. So I've got 5 and 15, so I'm going to cancel out the 5 and cancel out the 5 that's in 15 to make 3. I can also cancel a 2 here and a 2 here. I can also cancel 2 C's and 3 D's. Okay, this is a huge mess now, so let's see what have I got left. I've got 4 C to the power of 5, 3 D cubed. No, that's a 3 as well. You know, I could edit that bit out and you wouldn't know that I missed that 3 out. Especially because I have an erasable pen. Look, you can't even see it. Okay. I'm not actually going to edit that out because I can't be bothered. Okay, and that's my answer. I can't simplify that any further. So, yeah. Right, as a single fraction in its simplest form. So, we shall make a common denominator by timesing this fraction by m minus 4 over m minus 4. And this fraction I shall times by m plus 1 over m plus 1. And then I shall bring them both together, and I'm going to expand the brackets. Well, I'm going to expand the brackets on the top. I'm not going to expand the brackets on the bottom because there is no point. Because when you're trying to simplify a fraction, you want to factorise it as much as possible. So there's no need to expand. So let's see, 5m minus 20 plus 6m plus 6. 5 there's 11, there's 14. Minus 14. And this one, and minus 4. Alright, can I factorise that? Nope. That's concerning. Usually you can simplify it. So did I do something wrong? Nah. That looks right to me. Yeah. I reckon that's right. Question 12. We've got a circle. X squared plus y squared equals 20. And we've got the line y equals 2x. Right, little thing about circles for you. Just so that you remember, the equation of a circle is written in this format. X minus a squared plus x minus b squared equals r squared, where a, b is the centre and r is the radius. Now if you've just got x squared plus y squared and there isn't a number in a bracket, that shows you that the centre must be 0, 0, because there's no number. You could think of this as like x plus 0 squared and y plus 0 squared. So, why did I write x there? That was supposed to be a y. Okay. So I therefore know that the radius of this circle is going to be the square root of 20, which is 2 root 5. Okay, so I didn't even read the question, but I'm assuming that that's going to help us. That point there would be 2 root 5, 0. That point there would be 0, 2 point. Work out the coordinates of D and E. Do not use trial and improvement. You must show your working out. Okay. So I know that length there is 2 root 5, because that's a radius. And I could. Ooh. Okay. If this is y equals 2x, then for every step of, let's say, why can't I think of a letter? A. Okay. For every step of A across, it has to go up by 2a, because rise over step has to make 2. So, by Pythagoras, 2a squared plus a squared has to equal 2 root 5 squared, which is 20. I know 2 root 5 squared is 20 because I got that from square root of 9 in the first place. Okay, so 4a squared plus a squared has to equal 20. So 5a squared has to equal 20. So a squared has to equal 4. So a is plus or minus 2. So that means that the x-coordinate here would be 2, and the x-coordinate here would be minus 2, because this is the same sort of situation, but over there. And then in terms of the y-coordinate, well, I could substitute, well, okay, it's 4, isn't it? Because this is up 2, so it's going to be, right, D is 2, 4, and E is minus 2, minus 4. That's quite nice and neat. I suppose the other way to do it would be to say, if I want these two things to meet, if I'm trying to find the point of intersection, usually what you do when you want to find a point of intersection between two equations is you equal the two equations to each other. You do like a simultaneous equations type thing. So if we've got x squared plus y squared equals 20, and we've got y equals 2x, you can substitute that, because this is equal to y, you can substitute that in place of that y. So x squared plus 2x squared equals 20. And look, that's basically exactly the same as that. So, yeah, ends up being the same. Which is quite nice, I suppose. Any other ways of doing it? Probably. But that'll do. Number 13, here are 5 graphs. Okay. Aha, multiple choice. By the way, I don't know if you've noticed this, but AQA exams, they always have multiple choice on. It's really weird. No other exam board seem to do it. Even for like psychology and stuff, AQA is always multiple choice stuff. For each of the following statements, decide which graph is being described. Ooh, I don't know why, but I'm excited about this question. This is my idea of a fun question. The rate of change of y, right, let me test you right now. Do you remember I told you this literally Friday? The rate of change of y with respect to x is another way of saying what? That's right. Okay, I'm assuming you're right. That's right. It's dy by dx. I hope you did say that. It's another way of saying dy by dx, which is another way of saying the gradient. which is another way of saying the acceleration on a velocity time graph, or the velocity on a distance time graph, displacement time. Anyway, so where is dy by dx, in other words the gradient, where is the gradient always negative? Well, that's positive. That's neither positive nor negative. That's just like infinitely gradiented. So yeah, doesn't count. Oh, that one's always negative because it's just going straight down. That one's going up. Okay, so it's C. The rate of change of y with respect to x, just another way of saying dy by dx, or gradient. Okay, the gradient is always 0. Okay, so gradient is rise over step. So for this to equal 0, the rise would have to be 0. So it is D. It's flat. There's no acceleration there. If this was a velocity time graph, it's constant. It's not changing. So the gradient is 0. I've already forgotten what letter that was. D. And I don't know if you saw that video that I did. I think it was a Churchill one, where it was like, what two triangles are congruent? And I said D, but I wrote A. I don't know. That was embarrassing. And then I think Miss Bahia saw it and pointed out to me, and I felt really stupid. 13c. As x increases, the rate of change of y with respect to x decreases. Okay, so this is just another way of saying dy by dx, or gradient. I feel like writing gradient this time. So as x increases, the gradient decreases. Okay. So as x increases, so as we move this way, does this get steeper? No, it actually gets less steep. Because it's like, it's flattening out a bit. That doesn't get steeper, that's just always like infinitely steep. That doesn't get steeper, it's constant, it's the steepness, the gradient is the same all the way through. That's because it's linear. Gradient of that is constant, it's always just 0. Yeah, see this one, can you see it gets steeper as it goes up? And it's going to get steeper and steeper and steeper and steeper. So it's that one, which is E. Okay. Number 14. Rearrange that to make W the subject. Okay, and this is quite common, this kind of question actually. I see this a lot. So we can start by timesing by 5 minus 3W. And then I'm going to expand that bracket. And I want to make all of the W's together, because I'll need W as the subject. So I'm going to, let's see, I'm going to add that to both sides, and I'm going to take away 1. So I end up with that. Okay, and I need to isolate the W. So I'm going to factorize the W out of that. So that the W is now, I consolidated my 2 W's into just 1, which is good because when you want something to be the subject, you're only allowed one of them. Just realise how covered my hands are in pen. This is the life of a teacher. Hands are constantly covered in pen. Right, I'm going to divide by 2 plus 3x equals W. And that's the answer. Now, I don't know why this would happen, but I've seen this on other questions. Some students, you know, the way that they rearrange these things, it's all perfectly correct, but they end up with like, for example, you might end up with that instead of that. Now, this is actually still correct. It's exactly the same as that. The thing that's different is that everything here that's positive over here is negative. And everything over here that's negative over here is positive. So what's happened is it's been times by -1 over -1. But if you write that as your answer, I mean, it's technically correct, but aesthetically, it's kind of ugly. So you're supposed to, if you've got two negatives on the bottom, you're supposed to change it so that the top, you times the top by -1. So you change that to negative, change that to positive, and times the bottom by -1. So you end up back to that. And then just, just for aesthetics, we prefer 5x minus 1 instead of having the minus at the front. I don't actually know if you would lose any marks for writing this. I don't think you would. But, I don't know. If you got that, and then you wrote it as that, at least, like, that's on the safe side. If you wrote that, and then you tried to write that, but then you did something stupid here, sometimes when they mark these things, it says, like, ignore subsequent working, which means as soon as they see the correct answer, they can just give you full marks and move on. But there's some questions where if you get the right answer and then you kind of, like, make it wrong, then they mark your final answer, and that's kind of harsh. So, I don't know. It's up to you. Question 15. The nth term of a sequence is n squared plus 12n plus 27. By factorising or otherwise, when they say things like that, do it the way they say. Okay, there's a reason why they've told you to factorise. You can do it otherwise, but there's surely a good reason not to. Okay, by factorising or otherwise, show that the 20th term can be written as the product of two prime numbers. Okay, right, let's factorise it then. Although now I'm actually really tempted to do it by not factorising, just to see if I could. I could always try it and then edit out if it goes badly. I love being able to edit stuff. It's the best thing. Okay, so I factorised that, and that makes, wait, why, okay, the 20th term, I'll put 20 in there, so that's going to be 23 times 29. Ah, okay, which is the product of two prime numbers. I'll just write that 23 and 29 are prime. Okay, that's cool. No, there's no other way of doing that, to be honest. No, there is. Okay, it's not interesting. But you could put 20 into that to get the 20th term. You could work that out, and we have a calculator. 667. And then you just have to work out what the two prime numbers are at the times to make that, which is very difficult to do.